Professor Craven has built up an extensive library of people's dreams, all captured on video cassette.
Stop that, it's silly. Stop that, it's silly. Don't be silly, John, it's only a rucksack.
Lousy smarch weather. Do not touch Willie. Good advice.
Heard you guys saying that it could be too early to start this, but he said no to get the very gentle texture that Chinese people like. I have to start it now or it won't be any good.
Okay.
Oh, is that right? Well, excuse me, you're...
What was that? I asked for lobster brains. Where's the lobster brains?
And eggs and lobster brains.
Is he going to mix that with the white ingredients?
Okay, that's better. I feel like we can start now. Now that I've got my lobster brains, we can start. Hope everyone's doing okay tonight. Alright, so let's kick over. Assuming I can find the controls. To the stream. Hey. How's it going? We're doing another Fool's Errand Reversey update stream today. Since last week, I got a little bit impatient because we basically got everything in the introduction working.
Next, a World War II story with a surprising twist on beyond belief, fact or fiction.
Have you ever had the desire to write your initials in wet cement? Tempting, isn't it?
Only when I'm awake, Jonathan Frakes. Only when I'm awake. So let me easiest way. Let me just kind of fire up where we currently are with, because to start with, it's a big program, but we're just starting off with the prologue introductory animation, just to prove that can be done, and we got pretty far. We got more than far. Assuming I can find the right tab, which has a little crap in it. You know what? I can't, so I will just compound the problem by creating another another tab. Mabno says you made an interruption machine. it's not really, I don't really see it as that. It's more just kind of, I'm aware that the content of these streams can sometimes be incredibly dry, and I feel bad that I understand this is kind of, you know, it's mostly just kind of background entertainment. Like, no one's just sitting on their big TV just watching just this, I hope. But, interactivity is fun, right? We don't, I mean, this is a scrub tier stream. We're going to be scrub tier for life, which means
you give us
unfortunately...
as a result service during the games, and you put games.com on all your material.
Yeah, that's a good idea, games.com. The problem, yeah, so it's going to be a scrub tier stream. We're not going for affiliate, which then means we don't get channel points, unfortunately, which means that we just, you know, we have to kind of code our own tech, but I am more than happy with that. Rio Shark says, maybe I am. I'm here for the dry, like a hot, dry, sunny Aussie summer in the bushlands. Things are just too moist here every day of the year. You know what? As someone who just doesn't particularly respond well to the cold, I mean, it's a sweltering day. I've got the air conditioning like running at full tilt in the background, but I don't know. I've gotten to the I am elderly enough now that I get Raynaud's pretty often, and also chilblains, which means I have, like, after a certain month, I have to wear non-stop socks, or else I get like, you know, foot problems, for lack of a better term. So yeah. Do I even want to know what it's 27 degrees in this room. The air conditioning is struggling to keep it down to that level, but yeah, I feel for people who are currently dealing with like below 0 degrees. That I would just die. I wouldn't be able to cope. Wouldn't be able to cope at all. So games, max 68k, Z basic, full 2, ScumVM full, ScumVM fool's errand. So we should be able to... Mamu says, currently it says 0 degrees, but feels like minus 7. Yeah, in my neck of the woods in West Australia, generally the lowest we ever get is about 0 or just below 0. So no snow, but yeah, just a touch of frost. And but most of the time during winter, it's raining. So swings and roundabouts. Whereas during summer, which is what this is, it ranges between like 32 and 42 degrees Celsius, which, yeah, bad, but also don't have to, I don't know. Personally, I cope with that slightly better than I do the cold. But then, I mean, like, the flip side, though, is... Oh, actually, never mind. Doesn't matter. Can we go... The app? Can I change this to... Yep. So, you'll notice that we have text. We did not have that last time. It honestly turned out to be barely any work to make this... to make the font APIs work. Most of the hard yards have already been done in ScumVM as part of like the font rendering engine. In particular, like rendering Macintosh bitmap text fonts, that's already in there. So it was just a case of connecting up my Toolbox API shim with what was already there. And also, there is no longer a weird border around the side, which I later found out to be because the homemade disassembler that I wrote has one instruction that's like a 32-bit move, and it was mostly used by the rectangle draw feature, and I messed it up. I put in a -4, and I don't know why that was. Okay, so here's a thing that we're gonna have to look into. Like, there is still one screen of the introduction which does not render, but the text for the rest of the introduction, it renders perfectly fine. We can now go to the sun. We can look off the top of the cliff. This transition here, which previously wasn't rendering, now does render properly. That was due to me missing... I forgot to transcribe a draw command, and I think I got one of the destination surfaces wrong, but... And there we go. So, to summarize, introduction basically works. So... I guess the choice for tonight, like, we could continue... In fact, later on, it's probably just going to be me transcribing from ZBasic, which is... This is the output of my homemade assembler. It's basically just... It's normal Motorola 68K assembler, except with hints as to... Like, for instance, there is a fixed offset against one of the registers, which indicates that it's fetching from... the ZBasic heap store or the ZBasic variable store, and I've just gone through and added in, you know, nice little quality of life hints as to exactly what it is meant to be. There, and yeah, it's just, so this is, I believe, yeah, okay, so this is the main Fool's Errand executable as opposed to just the introduction. And there are, I guess, like some strings, but most of the strings are kept in another file called Fool's Puzzles. But in terms of code modules, we've got, so 128, and it goes all the way up to 144, which, if I understand how to do addition correctly, is what 16. There are 16 code modules, and I imagine they would kind of correspond to the different types of puzzle in the game, along with the, I guess, the top level one, which I think is like 120. Module 128 is the first module in the code, which I think must be like main, or potentially it could be the about screen. I don't know, but yeah, it's not clear to me as like exactly which module gets called first. I've just assumed that it was 128 because it was that way for the prologue. But anyway, so I'm in the process of transcribing module 128. I'm not going to transcribe all of it in one hit. Module 128 is about a quarter of the assembly language. Thereabouts, yeah, about a quarter. And yeah, the intent would be to... I mean, honestly, like, we could probably just get away with... Like, so far, how much have I managed to transcribe of that code? It's an amount with a number attached. Okay, I'm up to 1086, which would be about a sixth of a quarter. We could very well just spend some time getting that running. Like, we don't have to transcribe literally every module in sub 128. We can just stub the rest out. In fact, this may actually be a good time to start doing that, because as part of that rectification progress, like, I've just gone through and typed the C++ equivalent of all of these instructions here, but I have not gone ahead and defined the class which contains all the variables with all the correct types, and like, some of these types are definitely going to be wrong. Like, there is this string here, which I think is in the variable store, which is kind of used for a number of different things, including accessing different APIs. Like, I believe I saw like one function that was using that string memory to initialize a struct for the file system API, which is a bit... I mean, like, normally I'm a fan of the Macintosh Toolbox APIs. The file system API, kind of weird. Kind of very... You got to pass around like a massive struct and then read members back from it for the thing that you want. And only sometimes some of the members get updated, and there's like a big... You know, there's a big document in the inside Macintosh manual that tells you which is which. So, yeah, fun times. Okay, so what we're gonna do... So let's put that to one side. Let's just try and fix the remaining issues that we have with the introduction. So one issue that we have with the introduction, which hopefully should be like a nice easy fix. I'll start it up again so we can have a look. Is that there is a piece of code which is let me show it off. So starting it up here. Okay. So if you look carefully at the title screen, you'll notice that there is some garbage before the copyright symbol, and it's missing the letter D on the end. My understanding is that is because there is a piece of code. I don't know. So to go backwards a bit, all the Macintosh standard encoding is called Mac Roman. So this is well before UTF-8, probably well before the Unicode standard. Now that I think about it. Oh, actually, I don't know. I don't know if it's before the Unicode standard. It's definitely before UTF-8. But anyway, from a modification and localization perspective, like, it's quite a pain to... Like, I don't want the program internally to be dealing with stuff that could potentially be Mac Roman, because that causes, like, a nightmare when you're decoding stuff. So, I've been quite deliberate in this transcription, at least, to make sure that everything... I don't know, where's a better example? If I go into full prologue.cpp, I bet if I show you, like, the toolbox, the simulacrum of the toolbox API that I've made, yeah, you'll notice that all of the strings in it, at least all the strings that denote, like, characters which are going to be rendered to the screen, are of this type common U32 string, which is a type in ScumVM, which is like it's like a double wide string, so each character is 4 bytes, which is overkill, but then it means you can ensure that, you know, it uses, like, UCS4, I think, which is, like, the 32-bit Unicode standard, and it basically just means that if you're doing, like, character counting, you don't have to worry about, like a big bugbear with UTF-8, right, is that if you're doing string counting operations with that, there are some characters which, you know, there are some characters which can be 1 byte, there are some which can be 2 bytes, 3, 4. You have to basically, like, you know, scan through the entire string by hand to figure out how long it is. Or not by hand, but, you know, you've got to use, like, a special method and so forth and so forth. And of course, that assumption falls flat on its face when you mix in stuff like Mac Roman. So what we do is that we re-encode, like, we know that the strings coming off the disk are going to be Mac Roman, so we transcode them to U32 string, and then all of our toolbox APIs are going to accept U32 string. Ryu Shadak says there were 2 or 3 encodings on Apple Mac. Yeah, there were definitely, what's it called? For internationalization, there were obviously quite a few. Like, they had their own special version of Shift.jis, which I think was called 2-character display mode or something like that. Yes, but I think, yeah, but, like, the issue is that, like, the string that is going into drawstring, that is definitely a Unicode string, but somewhere along the line, drawstring is decoding that back to UTF-8, and then it is trying to shove the UTF-8 string through the rendering method, which expects it to be Mac Roman, which is just terrible. We don't want to do that. So I think what we need to do is improve, I don't know, like, see exactly what's going on and see if we can kind of unpick some of that a little bit. Okay, so where's the copyright message here? Because there's this big chunk of code here which preloads... Oh wait, sorry. prologue run, because there's a couple of programs jammed into here. Oh, Mamu says, I thought you were saying Macro Man. No, that's like a Windows 3.1 game, isn't it? Macro Man. No, this is Mac Roman, as in, I guess, the Roman I mean, it's not even the Roman alphabet, is it? Maybe, I don't know. I don't know that much about typing designation. Maybe it is Roman. Okay, so the way the prologue works is that it pre-renders as many of like the title screen cards as it can to buffers in memory, which it then just blitz during the intro sequence. So one of these is going to be the title card, and it is going to have some text underneath it, which says copyright Cliffrey Johnson. If I can. So I assume it would be this one here. It must be, right? Anyway, so we'll put in a breakpoint at 7:02. Just to confirm that we are in fact decoding it properly. I think we are, but my guesses have been off before. Okay, so we get a string, and this string contains, there we go, the double wide string 1987 by Cliff Johnson, all rights reserved. So, and we can confirm this by just looking at each character in sequence. Yeah, so we have, yeah, 169, 49, 57, 56, 55. I mean, honestly, okay, that is, yeah, alright. So I think that in, okay, at this point I'm probably going to have to open up a, continue. Okay, is there a table of every UTF-8 character? Universal coded character set. Comparison of encodings. UTF-8 character reference. Actually, what am I doing? I've got like a tool which will tell me exactly what I want. It's called Python. Python's great. So we want to measure this. So I believe Python internally uses UTF. It either uses UTF-16 or UTF-32. But that doesn't matter because we can go decode or encode UTF-8. Yeah, okay, so in UTF-8, we get, it's like a, what's the term for it? It's not a control character, but it is a, crap, I had it open, UTF-8. So it's got code point, prefix code. No, that's not the name. Okay, yeah. Okay, not a surrogate. I was thinking of a surrogate, but it's not a surrogate. it's got a prefix. So to indicate that like a code point is a higher thing, it'll encode this useless data in byte, well, you know, this signaling data in byte 1, which are then extended over the line. But that does mean that everything above character 128 no longer fits into 1 byte. It gets spread over 2 bytes. So I would say my hypothesis is looking pretty good, because we've got C2, which is not really a valid character, and then we've got this, which is the copyright symbol. Oh, sorry. Sorry, let me reframe. We've got these two, which is the copyright symbol. We've got that, which is the date. But if we then decode this as Mac Roman, which is what I think the font code is doing, yeah, we get this, right? We get copyright symbol 1987 and this diacritic mark, which I don't think is part of the font, that gets bundled in with the game. So, all right, all well and good. I suppose now we have to figure out... We need to figure out where in the code that string is being used. So we set the port bits, we... Oh crap, okay, no, I skipped right over it. It's this command here. That's okay, we'll just start again. Start anyway. Okay, skip, draw some text align. Okay, so it calculates how wide the string is going to be. So it's going to be that many pixels. Moves the pen to the right spot, and then it tries to draw the string. So this command is having problems. So we create a temporary buffer, we then fill it with a background color, and then we draw to that. Okay, so it's going to be this command here. Okay. I see. Okay, so the automatic downcasting code has converted this, has, what do you call it? Converted the U32 string to a string which is only going to be, which is always going to be UTF-8, which is unfortunate for us. Just, yeah, one of my least favorite things about C++ is that casting is mostly automatic, and if it can convert one thing to another, aka if there is a function or a copy constructor, or a constructor or a copy constructor with the right type in it, then it will just automatically convert it, which can be 100% what you don't want, and you only find out when you trace through. So isn't that okay? So that's interesting here. So we've got, like, why is it not calling this function here? Why is it not calling the function which is exactly the right like, it's going out of its way to make me to do it wrong, which is frustrating. Yeah, okay, so we've got methods which accept U32 string as as a parameter, and it is choosing not to pick them. So I guess we gotta... It's gonna be one of those cases of either I screwed up the type or... Okay. Alright, that's partly on me. So I don't know why I put encode in there. Maybe I assumed it wouldn't be there. Anyway, okay. That's good. It means that the compiler was in the right and I was slandering it for no reason. 70 full prologue CPP 702. Alright, so I found the bounding box. It did all this. Oh, thank God. Alright, and we're at the right, the right method now. Okay, so draw string. Yep, it's definitely 32-bit. Okay, then it goes to this one, which is of type string type. Then it calculates the string width again. Okay, and then it does the iteration properly. Okay, so I think that should be enough to make it. I mean, okay. I hope that should be enough to make it better, because it is not gonna. It's not gonna get 2 characters anymore. Okay, so we've got an iterator. Okay, it's got that the character ID is 169, and then eventually we go to draw character. Then we get find glyph. Interesting. Okay, so I guess the last character in the font that it's got is the copyright symbol. Okay, so maybe that's fine. Maybe that's all good now. Maybe problem... I mean, it looks solved to me. Looks good to me. Okay. Okay, so that was problem 1. Problem 2 that we have with the introduction is there is a scene right after the High Priestess does lightning from the hands, which is meant to show like a little overlay over the top saying, and no one can undo what I did over the land or something like that. That isn't happening. I should be able to show it off. Actually, I've got MAME open because I was doing a little bit of tracing of the Mac Toolbox API, but we should be able to just continue on. So... Oh, except everything's been moved out of the fast memory, so it's going to take a little while to... Uh-oh. Did I break the stream? I might have broken the stream. Oh, no. Uh-oh. Okay, we back? Sorry, we probably dropped some frames there because MAME be like that. It's kind of like turning on a like one of those enormous mining trucks from a standstill. You gotta start on really low gear because there is a lot going on. So BP disable 4, BP disable 3.
Smithers, are they booing me?
No, they're saying Boo earns. Boo earns.
Are you saying boo or boo earns?
I guess we'll never know. We'll never know if they're saying boo or boo earns. Okay. So this bit here is meant to be a nice kind of seizure-inducing screen flash effect. That isn't working, I'm guessing, because I have not put a delay in the right spot. One difference between the original code and ours is that our code only updates the screen once the CPU yields to something, whereas with this, interrupts are handled by a timer, and this has got to work on hardware from like 1987, so it just ran as fast as it could, and then it just checked what the ticks were. So for an effect like that, we would need to put in a manual wait. Also, it would be kind of nice to add in an engine flag to maybe turn the crazy flashing off. This game does have like a fair amount of that, just because the XOR blit is it's one of the, you know, it's like the equivalent of color cycling on the black and white Mac is just doing an XOR blit over everything, which then, you know, inverts things over and over again. But what was it doing? Okay, I was going to run. Yeah, okay. So there, it kind of fades into this little text here saying, "For no one can undo the treachery I have inflicted upon the land." And I was kind of, I'm kind of thrown by this. Actually, there's a two-parter to this. So the default Macintosh graphics format is called PICT. It is, more often than not, people just use it for storing bitmaps, but it is in fact capable of bytecode. And the bytecode just does like a, you know, a subset of quick draw instructions. The bitmap, or the PICT file for this text overlay is just a bunch of lines. So the fact that it is not rendering here makes me... That's right, yeah, there was we don't support that type of image in the ScumVM PICT, the PICT loader. At least, not yet. Not yet. Ryu Shinaka says, so PICT was a sort of primitive SVG. You can kind of say that. It was a page just, you know, it's got a similar kind of, what's it called? The layout description language was also used for, like, page layout. So, like, the feed that was going to Apple's laser writer printers was based in a large part on the quick draw commands and the quick draw tools. And there's like a similar kind of you notice there is kind of, what's it called? There is a similar comparison in the Windows world where like GDI, which was the API for just drawing primitives and stuff to the screen, nowhere near as nice as quick draw, gonna say it. GDI, not great. But it was ubiquitous enough, and it also worked as a printer. It had the concept of like using a printer in the same way you would use a monitor, so that then kind of, you know, you could use that to drive a printer as well. And ultimately, a subset of that became formalized as something known as PCL, which is, until recently, that was the lingua franca of most printers. Like, most printers would support a PCL input, even if it wouldn't render it very well. Mostly now we don't. Well, we've got like a better option because pretty much every printer that is Wi-Fi enabled now supports IPP anywhere, because Apple controls cups, and Apple basically said, if you want your printer to be able to accept jobs from an iPhone or iPad, you are going to support this standard to the letter without any deviations. And for the most part, the companies did, and that generally means you don't need a printer driver anymore. You can just send stuff in IPP anywhere format. Fortunately, we don't have, I would kill for the same thing with scanning. Apparently, there's sort of that if you have a multifunction device that's attached to the internet, but if you just have a device that is attached via USB, you're SOL. It can be whatever the hell they want. Okay, and that was about 8 tangents. 8 tangents crammed into one sidebar. Okay, pictures. Image? Yeah. Pict.cpp. Okay. So we've got the opcodes in here for pen size, pen pat, short line, etc., etc. But at the moment, none of the line drawing commands, or in fact, there's actually like code for the line drawing commands in here. They're just not present in the
1 hour was really short. Totally different from my own kitchen. Not so.
So. Okay. So if we go to the prologue, we've got to find which of these. Okay, these are the cliffside images with the lightning. This, I think, okay, that's the High Priestess skull, that's the High Priestess's face. Priestess on the mountain. Priestess shooting lightning. Priestess lightning close up. Okay, and then the ones immediately after that are the ones we're interested in. Okay, so that's good to know. So what I'm going to do is I'm going to turn on the debug. Yeah, okay, we're going to turn on this debug level G graphics. And then put in, yeah, and then put in a breakpoint. Full prologue, CP 782. Start. Okay. So we can see here, like, running against the other images is fine, because it's mostly this pack bits rect command, which is, I believe, the one which just draws pixels. Now, if we look at this next one, okay, so the next one is fine. This one, this is our problem child. This is, oops, all short line. Oh, sorry, pen pat followed by short line. So we gotta implement that in our pitch decoder. Okay, so is there something which currently so you know what? I'm gonna uncomment these. The next question that we have is pick.h. So we're probably gonna have to add draw line function into here. But that's not too bad. Now the bit that was we also need pen pattern. Okay, so pen pat, it does save the pen pattern, which is good. Does it actually use the pen pattern for anything? No, it does not, but that's okay. Does it use like pen size or anything? No, it does not. But that's alright because we don't need to set the pen size. We can just pretend that it is normal. Okay, so where are the rest of the utility functions? So we've got unpack bits line, skip bits rect. Okay, we'll just put it underneath here. And ideally this shouldn't be too difficult because we've basically got an implementation for this. I would... So like, how does the unpack bits... How does this work? Okay. So it does read the palette if there's one present. We've got all this. Oh, Kineko says, so this is mostly just reversing engineering classic macOS's toolbox. That's part of it. Like, what we're doing here is adding in a feature of the picked format, which is, I guess, part of the classic macOS. But the game itself is very much in, what's it called? It's in Motorola 68K assembly, but it was originally BASIC, which has been compiled to that, so you can kind of... It's not optimized anyway. Like, you can look at this, and you can basically see the building blocks put together. So, like, to give an example up here, so... They basically always use one or two registers. So, it is always take a value from the heap, and then put it in the register. Then push the register. So you can, like, say, alright, that's going to be an individual thing, that's going to be an individual thing. And in this case, it's before this trap. So it's pushing 3 values to the stack, and then it is calling this this Mac toolbox function, for instance. So, like, if it was a conventionally compiled program, there would probably be like a lot. I don't know. We'd have to use. Well, for one thing, yeah, we would probably need to use like Ghidra in order to just kind of keep everything straight. Whereas with this, you can make, like, for instance, like this. The fact that it's marked heap here is because there's like a certain register offset, which then is always used by ZBase to say, okay, this is referring to the memory, like the array memory, or this is used for the variable memory. And then my disassembler sees that and then just converts it to something which is easy to read. Kinigo says, I'm also so fucking happy that the guy who made Space Quest 1 in the 27th century decided to release it for free. Or pay what you want. Oh, neat. Oh, Star Quest. Okay, I was gonna say, yeah. I know that there are like some names which are kind of reused a few times, but I wasn't aware that Space Quest was. But yeah, Star Quest. Okay, makes more sense. Okay. So where were we? We've got to figure out. I think initially I would just be happy to see what values are being kind of shipped to the draw line feature. But I mean, okay, we can so like the trick here, if I go like draw line or line 2. So our implementation of line 2 is definitely nowhere near as compact as the original, but there's a good reason for this. At least I think so. So, because drawing in the Macintosh Toolbox API can be one of 8, or at least in Classic Quick Draw, you can be one of 8 different blending modes. So we're talking like monochrome blending modes, like, you know, copy or exclusive or just erase in the background, and then there's like 4 knotted versions of that. So in effect, to kind of keep that sane, and so that we can reuse the existing primitives drawing mechanism from ScumVM, what we kind of do here is we draw this. We always draw whatever it is to like an intermediate buffer, and then we blit it using this special blitter function here, which applies the bitwise blend mode. And we kind of have to do it that way because there is no. I don't think there is any concept in ScumVM of a monochrome surface. There is only 8-bit. So we're rendering in monochrome, but I think due to the fact that we are using the Macintosh window manager code out of the box, that means that the color black is at index 0 and the color white is at index 4. So you can't make any assumptions about, oh, it's going to be this number. You have to. Anyway, so definitely more layers of abstraction, but on the whole, like, this runs perfectly quickly. Like, blitting is generally quite cheap so far, which I'm kind of surprised by, because in director code, the blitter is just it's massive. It is very, very heavy, and I wish that we could simplify it. But then again, that's all of the blend modes require per pixel operations, and then that in itself is just a nightmare. Bloody Cactus says, since pict can have embedded bitmaps inside it, could that other bitmap be another pict image? Good question. I think the answer is no, because embedded inside the it's not really an image. It's not really a bitmap that's embedded inside the pict. It's not like another sub-pict. It is an opcode of type pack bits region, which contains raw data of a fixed format. So you can't, as far as I'm aware, you can't nest picts. If you could, then I'd probably just give up. I'd just say you don't need to see the image. You can live without it. Just work from context clues. Oh, speaking of context clues, I just completely beefed the coordinates here. Forgot how Cartesian works. Okay. Alright, now, if I wanted to use the primitive graphics drawing thing, we need to inherit from this. Hey, Crushing Ceiling, how's it going? We're trying to get the last missing piece of the introduction, which is this screen here, which uses a special line drawing picture mode, which we do not have yet. Okay. Now the thing is, we kind of work around it here in our renderer by pulling in the one that's attached to the Mac window manager code. I don't really want to do that for the pict loader if I can avoid it, because there's quite a lot of baggage attached to that. Like, I can get away with it because we're using the window manager in the full engine, but I'd much rather copy what the full engine, what the window manager code is doing and apply it to whatever format that the pict loader has. That seems like it would be more sensible. So if we go graphics, oh, it's all in here. Okay, so we have right, okay, so it uses Mac draw prim. Where's that defined then? Oh, it's defined earlier in the file. How about that? So I think if we were to do this, we'll just do this here. Like, yeah, you can see some of the baggage here in Mac Window Manager is that the Mac Window Manager code doesn't really deal with the 8 blip modes yet, so it has like a completely separate primitive object just for drawing inverted, and that's got a bunch of bugs in it. So yeah, we kind of sidestep that by always, we do not deal with the blending mode in the primitive drawing function. And we can probably speed things up by moving in there. It's just super messy, and I got better things to do. What I want to know is, where is this defined? Where's draw point? Oh, it's down here. Okay. So we'll copy this for now, but it'll we should be able to simplify this a wee bit. Okay, so unpack bix rect. Okay, reads raw pixmap data. Does it? Okay, does it? Yeah, and it does it by line. Okay, and then part of that is... Yeah, okay, so no, it infers what bytes per pixel is, which is a problem. Output surface create. I think if we assume that the output surface is 8-bit, which I think is what we do, we should be okay. Okay, but it's all going to this output surface thing. I see. So it creates it and then... Yeah, okay, and then it just writes it to the base pointer, which makes sense. So in here, we want to scoop out all of this. We want to change this to be whatever our picked class is. Because, yeah, alright, and we've... Alright, and now we're gonna get into the weeds of friend classes. How do you define a friend class in our friend C++? No Stack Overflow. Okay. Okay, so you can... Right, so you can define it in here, which is good. So we'll just go... Friend class picked decoder. Which then means we can get to the pen pattern. What do you mean it's a private like we sorted that. It's a friend. Oh, and I didn't define the class name. Okay, fine. Yeah, it's a private member of... Oh, okay, no, I get it. You gotta do it the other way around. Gotta do it the other way around. Template picture trimmers cannot be referenced with a class specifier. Okay, you know what? No templates, I've decided. We do not need templates. Use of class template picture or prim... No, it doesn't. What are you talking about? There's no template arguments required. You're overthinking things. We don't need that. Okay, so what was the opcodes? This is like PN size. Okay, that's relatively cheap to implement. So now we have to go pen size. Okay, and now we can simplify this a lot because we do not care about the invert function. Which means we can just destroy this and replace it with that. Do we keep track of fill origin? I don't think we do. So we can just simplify that to like 0, I suppose. Okay, and then do we keep track of the pen color? Where are the opcodes? Okay. Oh, there's like large swathes of opcodes that aren't here on the list. That's nice. Pictures 2 created with the open picture function and color graphics port use the picture opcodes of the version 2 format. Okay. So yeah. It's so yeah, this is kind of like PDF or SVG. It's kind of like how with Cairo you can do a bunch of operations and then output it as an SVG. This is just a format that allows you to serialize a bunch of quick draw commands. Okay, well, not going to worry too much about the commands which are not implemented yet. Interestingly, yeah, it's not all of them, and it is quite there are differences from the QuickDraw API. Like there's no pen normal. You have to set that up yourself. Which is an odd choice. Okay, now if we were to go back to the thing that was running. Okay, so it does clip, then does pen, it sets the pen pattern, then it does a bunch of short lines. I would like to know what the pen pattern was set to. I assume it would be to the white color. Actually, no, it might not be, because you see in the Macintosh in the Macintosh monochrome bitmap, 0 is white and 1 is black, which is kind of the opposite way you'd expect it to. It's the opposite way you'd expect it to work for most bitmap graphics. But that's the way they picked. I mean, wait, was there originally a loop? Did I get rid of... How come this doesn't have a loop? That seems wrong. Why is there no loop? Okay, it's checking the thickness is equal to 1. Oh, because it's... Okay, no, I take it back. Sorry, it's... Yeah, so this is for drawing a single point, which then gets extrapolated to a line. So, yeah, it would only touch 1. Whereas if the line is thick, then you have to touch multiple pixels, which is a thing. Okay, so to simplify it, we don't have the mask, get rid of that. We... Okay, let's just say that the background color is white. It doesn't matter if this isn't perfect. In fact, it's encouraged. Okay, I've changed my mind. I actually want the templates. I want the templates back. I'll regret it moments later, but for now, I need them back. Template, type name T. Explicit serialization of undeclared tempo class. Yeah, okay. What am I doing? What does it look like I'm doing? Oh, okay. You don't include the T there, but you do include the T here. Okay. Use of class template, picture or print requires template arguments. Like, what do you think I've been... Okay. We did that. We added a template argument. Oh, okay. Goes here. Okay. Okay, so we'll get rid of this, which we don't need anymore. Remove the origin, which we don't need anymore. Oh wait, no, because that's... I see. They're not in... they're not in a block, but that is. Okay, so we've got our primitives. think what we'll have to do is... Oh, cool, it can be 16-bit too. Great. Love it. Nice. Okay, so I guess that would then be UN16? Yeah, okay. Because there are multiple points in here which can then change the format of the surface. So I think we're just gonna have to deal with it. Or we could just, you know what, we don't even need to cache it. That's probably overthinking it. We can just do it every single time. Okay, so we've got the short line, okay. We'll say pick what's the name of the surface again? Output surface, of course. Format. Okay, and if we're being consistent, this should be XO. XO, YO, X1, Y1. Color should be... Color is a good question. It would be whatever Quick Draw says the default color is, which we have. Full prologue. Okay, so normal mode for the pen is that we're in copy mode. It's a size of 1 by 1, and the pattern is solid. solid black. Okay, so how does the rest of the picked code choose what color is which? Color? Any mention of color at all? Just any. Okay, there's unpacked bits per line. Output pixel buffer. Oh, okay, it can have its own palette. Oh, that's unfortunate. Okay. Which would then... Okay. So at the moment we don't really have any concept of colors or anything, so I think we're just gonna have to... Okay, so we'll say 1... Okay, so Alright, so the 16-bit mode is RGB 555. Which is fine. Then here we have RGB 24. Okay, which it then up converts to RGB 24. Oh crap, it's 3 bytes per pixel. Okay, dang, alright. That's a mistake. 3 bytes per pixel sucks. Then... Oh, there must be like a padding byte, I guess, for RGB 24. Because like the problem is like you can't access 3 byte, like 3 bytes is unaligned. 4 bytes you can fit into 132-bit int, but 3 bytes you can't, and therefore that means like pointer access does not work the way you'd expect it to work. Bytes per pixel, RGB. It's like, why would you do that? Why would you pick this? Or worse, why would you pick this for both? Alright. Yeah, because like all of this depends on the fact that you can... I mean, actually no, I take it back. It fetches... It's like get pace, like how are you meant to... Okay. Alright. Surprise me. There's got to be some code in this project which uses create RGB24. Oh, only 3. Or because it's kind of an odd choice. Okay. Right, and then... So, okay, so basically up converts it. Because it's weird and no one wants to touch it. But look at all these happy engines that are using RGBA 32. A graphics format engine, you know, that you can do math on. I mean, I'm seeing this as a sign that we should get rid of RGB24. Any other place that use it? Oh, okay. I mean, all right. The image decoders use RGB24, but I wish they didn't. Now it says RGBA 32 is for cowards. Like, come on. I don't want to have to write. The problem is, like, I'm lazy and I don't want to have to... I don't want to have to write code for the 24-bit case. You know what? I'm just going to put a fix me in there because that's going to take too long. crap. Where did I even go? Where did my thing even go? Ah, it was here. Okay. Because yeah, you can't do this. You can't just change one color with one right. You have to do 3. And then all of a sudden, this template nonsense no longer works. And yet both 3 and 4 decide to use the cursed pixel format. I think it's that. Screw it, we'll just do all Fs. Okay, okay, that was me forgetting a thing. Okay. Now, which was the terminal which had... Which was the terminal which actually had the thing in it? Was it in here? Yes. Seven and 82. Okay. Okay. Did that? Oh, it's here. Okay. Okay. So this picture should be the one with all the lines in it. Yep. Did a bunch of lines. I guess we'll see if they rendered it all. In hindsight, I should have put in debug statement saying what each of those line commands were doing. But that's okay. Alright, we can't see anything. That's unfortunate, but whatever. We can let's put in a breakpoint for the picked code that we did. Decoder, draw line. Hey KPR, NCP. We're in the middle of porting over a game from the original Macintosh to ScumVM, which is this nice abstraction layer for running old games and stuff on. And at the moment, we're just in the process of fixing the introduction, which we kind of just we did that as like a test case, and most of it is fine, but there is one section of the introduction which uses I don't know, the image format allows you to have just arbitrary instructions in it, and one of the images in the game has a bunch of lines. So we're gonna yeah, we're in the middle of trying to like fix that last line and then getting it going. Hey Summer, how's it going? Oh, thank you. I'm glad you approve. It is quite hot today, so anything which I don't know, Poplin is nice. I like that Poplin breathes. So okay, just gonna get through all of this. There we go. Okay, drawing the line. So we're drawing a line from 216 to 382 by 222 to 382. Okay, those are all legit legit positions in the image. Okay, so it does all of this stuff. Right, okay. So there's this top level function called drawLine. And then that calls drawPoint, which is the actual thing which blitz stuff to the surface. And if we look at, so we go into drawPoint, which is going to be the function that we just made. What is it? Output surface. Okay, so output surface get oh no. What have I done? Okay, here we go. P output surface get base pointer 0, 0. Okay, so by default there is the surface is filled with nothing. Does the surface have a palette? I don't think it does. Oh yeah, and
Your engine oil pressure is critical.
oh, thank you very much for the follow. KPRNCP. Apologies, I've pronounced that horribly. Yeah, good to have you around. Tell me about this pen pattern. Okay, so the pen pattern by default is all zeros, which, because it's opposite world in Macintosh land, that means it is the color. It should mean it's the color white. So it should just be drawing just the background color, which by default is white to the surface. And did I... Okay, and then the color that I've put in here is 1. So okay, so then that potentially means that it is, oh my god. So like then the tricky part becomes like, okay, this is a surface that is full of 0, which counts as the color white. And then we are drawing a pattern, which is all zeros, which I think was set by the penpat command. Because the default pen pattern is all 1s, but they changed that. So, but if it's drawing like white lines on a white background, then we're not gonna see anything. Oh, no worries, KPRNCP. Yeah. Good for you to stop by. We need... Okay. But maybe what we should do, and this is a mad thought, what if we were to open up an emulator, a different emulator, just Basilisk, go to 256 color mode, open the Finale and ResEdit. So ResEdit lets you look at all the picts that are part of the thing. So there is this background image here. And then there is this image here which contains all of the lines. And I wonder that, like, is the intention here that the pict loader is meant to just run, just do this live, in other words. Like, it's not meant to kind of pre-render anything to a surface at all. It is just meant to, it's just meant to draw the contents of the picture live. Because if that's the case, then our approach here of like decoding it to an image is not going to work, because the default for an image is for, like, the default background color is white and the color of the lines is white. And I don't know how you square that circle. I don't know how you you fix that. Well, I mean, well, correction, I don't know how you fix that in the image loader, because technically it's correct that there is a white square. I don't like it, but it's technically correct. The worst can't be correct. So if we look here at my beautiful C crappy rendition of what's going on here. Alright, that calls prologue buffer next picture. Okay, which is a method which calls the get picture toolbox ID. Let's look at what they have to say in our friend Imaging with Quick Draw about get picture. The get picture function returns a handle to a picture stored in the pict resource of the ID. Okay. You can pass the handle to the draw picture procedure to draw the picture stored in the resource. Okay. So it so it does not pre-render anything. And then we look at draw picture, which I think has been called by the other helper method. And we get to draw a picture of any type of output device, use the draw picture procedure. You must access a picture through its handle when creating pictures. The open C picture, return the handles. Great. So you handed a picture handle, and then you go at destination rectangle specified in coordinates local to the current graphics port in which to draw the picture. The draw picture procedure shrinks or expands. Okay. And we kind of work around that Really? Was... Yeah, okay. We have like pick handle. Oh, because we use... Okay, because there's a Z basic method called picture. And the Z basic method called picture does... It does a copy bits. When in fact, we should probably be... see, I understand. Okay, alright. So one potential way that we could make this better, we could have a mask surface inside the pick decoder, and then that would mean that when we do our blit, I mean, that basically means like we have like a second surface which is just for saying whether or not things have been drawn to a particular area. And then we have the option of saying, well, our blitter already has a method where you can say, okay, here's like the source image and here is the mask to cut out and only draw the pixels from the mask. And then if we did that, then we would not have to worry about, because you can do like a very similar kind of thing with paletted graphics, which is basically say, all right, this vibrant shade of magenta or this acid green is going to be the transparent color, which you never see. But that's very difficult to juggle if you have if you don't have full control of the graphics. If you have a graphic which needs exactly 256 colors, you can't really sacrifice any of them just for your own engine's internal transparency. And it's also very expensive to convert like index graphics to and from 32-bit. However, a mask surface is kind of cheap. So and it works with any shape you want, so I'm liking that idea more and more. It'll also be backwards compatible with the old pick decoder, so I won't break any of the other engines. So I think we might do that. We might go, because at the moment there's like output pixel buffer. Okay, these are all like internal functions. There is this kind of image. Okay, and then there's like the stock methods of the image decoder, including this like get surface and get palette. Let's just go const graphics surface, get surface, or get mask. Okay, and then in here we do this. And then it's just a case of and this, I suppose, yeah. Okay. So we've created our mask surface. We the annoying thing is we now have to like clean up the mask surface wherever we do it as well. Okay, yep. This... Yeah, okay, so then there's this method which does all this, I suppose. Y minus image rect top. Okay, and then there's like unpack bits by line. Oh, actually, no, that's not right. Okay, screw it. I see, okay, so then that... Okay, so this unpacks it to a rectangle inside the image, which must be in here somewhere. We have a planar 32-bit surface, we've got all this stuff. Oh, and okay, and it does it using the horrible maths. Okay, this creates a new surface and then does the mem copy. At which point it's best to just fill the entire thing. Okay, but then that means up here, where we are drawing, we can say P Okay, so we have that. All right. Well, it's an improvement. However, now we run into another issue, which is that our quick draw code from like load, was it get picture? Yeah, it fetches the stuff from this stream, but it does not what do you call it? It remaps the surface as opposed to drawing it. And then, you know, that brings us back to square one. We don't, what we have here is yeah. So we have two options. We can, yeah, we have two options. We can change the type of pick handle so that it actually points to the decoder, and then we implement draw picture, which operates on a handle of type pick decoder, and then that step is responsible for blitting the final image out of the image decoder. You know what? I'm like, yeah, okay. I like that idea. So it's a little unwieldy, but then that should also, regardless of like whatever kind of weird crap goes on, we should be able to manage that. Okay, so we're going to go into toolbox. We're going to change pick handle to be of type I think it's image pick decoder. Yeah, it is. Okay. So that's now here. We then also need to get picture. Okay. So does anything else use pick handle? That I suppose. Okay, that's all fine. Okay, now we gotta go into here and change pick handle decoder equals new image pick decoder. So now this stuff in here needs to be moved into draw picture, which is going to be the new method. So we're going to grab all of this. Oh, yeah. That's got to be in there. So... Okay, graphics, managed surface. What is that? Okay. Okay, so we got this create remapped surface function, and I pretty much nicked this from the scum code, which has a few cases of this, but it turns a mono bitmap into whatever weird palette that the window manager uses. So it just creates another surface, in other words. But that's okay, we can... So we've got that, and then we'd also need to const graphics surface equals picture get mask, and then we'll just call that the mask, and then at this point we would need to do whatever the z basic method does. So we'll be calling the copy bits. Oh, okay, so one problem with using the copy bits API though is that does not have any concept of a mask. So it would be, we would want to do what copy bits does, but yeah. Actually, does draw picture... Oh, it shrinks or expands the picture as necessary to align its borders with the bounding rectangle with the oh, okay. Really? You had to do it that way? Okay. That complicates my job somewhat. Or it means we have to like copy more than I was hoping that we'd have to copy. Because this... Yeah, alright. What we're gonna do... Because I'm trying to keep this API as close to the original as possible, so I don't lose my mind at the differences. But what there's nothing stopping us doing is making an internal one, which is undocumented. And this one contains a mask argument. Okay, so we've got all this. We no longer need to define mask because that is defined up here. And down here we can call our internal copy bits, which contains the mask. I guess we could... Oh, okay. This also fixes another grievance I had, which is that ownership. Like, ideally, I don't want any of the... What's it called? So, I put this in because this is the same argument as those, but bitmap is a shared pointer type, which means it is reference counted, and if this... That does not work, because at the moment, like, all these services here, they are owned by... they are owned by the pitch decoder. I don't want to move them into a shared surface at all because that would be bad. And I also don't really want to copy... I don't want to copy the handle. That would just take... That would take long. So I suppose given that we've got this kind of like nasty API here, we could change that just to manage surface. So we do that, and then we go back to our... Okay, and then we'll have to change blip mono. Damn it. Do I want to do this? Does this seem like a good idea? I take it back. Keep it all like that. We'll just make a copy. Copying is so fast, you guys. So much easier than thinking. Just make another copy. Okay. All copying all the time. No conversion from graphic surface pointer to const managed surface. Copy from... Ah, yeah. Actually, screw it. We don't need to do that. We can put it here. Okay, then we got port bits. I guess source rect is just the entire thing. Oh yeah, so fine. Passes any picture of comments to the standard comment procedure. Always use the clip rect procedure to specify a clipping region. Doesn't really talk about if it uses blit modes. I don't think it does. Because that'd just be hellish to manage. But whatever. Now we can go back to ZBasic here and change this to okay. I have the feeling that this is going to cause loads of problems. It's going to... Okay, well, it's not going to build for starters. Binding reference of type to thing... Where was that? That was in... Toolbox quick draw at CPP. Oh, because I didn't... I mean, that's a const. What do you want from me? Binding reference of type. Oh, because I didn't define it as a const up there. Fine, alright, sure. 101. Oh, because Blit Mono doesn't treat it as mask, but that's okay. We can do that. So we made that const. Const. There we go. Const all round. Pictocoda does not have no member named W and H. Interesting. Okay. zbasic.cpp. Yeah, I know. I know it's a pointer. You don't have to shout at me. I agree. Okay. So who wants to take a bet that everything is busted? And like none of the graphics render properly? Because it's an almost certainty that that's going to happen. Given I was messing with such foundational pieces of the stack. Okay. Yeah, alright. No pictures. No pictures is what I'm taking away. No pictures, only void. Okay, so what have I done? I have done a number of things. But chief among them is that I've forced it to start using this mask. So just to confirm that the pict loader is fine, it's just me missing out on something. If I were to go into quick draw again and just comment this line out and we just go const bitmap. Like that should revert things back the way they were. Good, good. Alright, so issue here is that all the graphics are reliant on packbits rect. And packbits rect must not be it must be, yeah, what's it called? We must not be setting the mask properly in there. Okay. Pack bits rect. Oh, okay. I see. Alright, so we need to... This is unpacked bits actually called? I think it must be. Sure is. Okay. That makes sense. 1, x1, y2, x2. Image rect. Yeah, so we need to modify... We need to modify this to... I mean, we can do... There's like a super easy way of doing this. X pause, Y pause. There. We literally just... Whenever we set a pixel here, we just set a pixel on the mask as well. Okay, so if I go back into here, turn that code back on. Will that count? Yeah, I'm curious to know if the images are going to display okay or if they're going to display bad. Okay, it's promising. Seems to have... Also, the raindrops which kind of get etched into the background, I believe that happens in the original as well. That's just an artifact of how the code works. The code... Alright, we got the background. We do not have... we do not seem to have the image which was made from all the short lines, but we do have the thing that was meant to be underneath it, which is good. Did I even add? I think I did add code to the to the picked thing for line drawing, didn't I? Yeah, I did get it to set the mask, so what gives? Anyway, that's better than we were before. I don't know, what I was worried about is if there is compressed pics which kind of, like, say this tree, say that this image is drawn by, like, just the bits for the tree, and then just the bits for this rectangle, and this and this and this. I mean, technically, then that just means the rest of this becomes a void, which I guess should be alright if you're rendering it to a surface using draw picture, as you should. Then that would cover that, I imagine. So fine. Good and fine. Fine and good. Alright. In that case, what I want to do is I want to go to this API here, which draws the picture. In fact, I just want to my picture get mask debug print. I gotta do it in code because it's a massive pain in the ass in doing that in GDB. I wish it weren't, but this is where we are. Ah, it's here, okay. So now we should be able to see the mask of each of these pictures as they are drawn to the back buffer. Okay, so that seems to have done most of them. Okay, as expected, all of these are just copying bits to the screen, so the bitmap is just going to be full. Okay, then we get to our friend here with all the short lines. And I want to know what... Wait, what? I guess that isn't drawn to a buffer just yet. Oh yeah, that's right. That's... I think that isn't drawn to a buffer just yet. Okay, now it just renders everything to the buffer. Okay, and then we've got this one, which is this background image of the priestess. That's all filled in. And then we have this one here, which is the lines, which is completely blank. Don't know what I expected, but actually I do know what I expected. I expected it to be full. So, what is wrong? What is wrong with the pict code? Like, it should be calling this for just about everything. X0, Y0, X1, Y1. Yeah, these are all valid. These are all valid points. Yeah, sure. Oh wait, is there something that's just nuking the mask surface afterwards? Because that could happen. Oh. Why is it... Oh no, okay. That's not supposed to happen. Oh, alright. Because it's set to 0 by default. Okay. That's on me. So we have this value here called pen size, which is like the number of X and Y pixels that like... So, you know, normally you just want it one by one, but quick draw, you're allowed to set it to whatever X and Y size you want. And I forgot to make that. This. So once again, doing exactly what it should be doing. But I was too, I'm excited. Maybe it's actually going to show stuff on the screen now. Okay. Yeah, alright. So those are all these bitmaps, which we know are all kind of full mask. Then we have look at that. Look at that. Okay, it's wrong. It's completely broken, but well, I say completely broken. I reckon it looks like what's it meant to look like? It's meant to look like this. And if you kind of squint, like there are the oh my god, please, please, Cinnamon. I know that it's frozen. I don't care. I just don't care. Wait. Yeah. Shut up. Okay. Okay, 3 periods here, 3 periods there. 4, no one can undo the trade. Okay. Yeah, so we've got X and Y mixed up, which is less than ideal. And then there just seems to be... Well, we have X and Y mixed up, but... the coordinates... Like, I don't know, like, maybe it's kind of like we've got the start position, X and Y mixed up, but then, like, the actual line is correct, because the lines do look like they are horizontal. Okay, that's an odd artifact to have. But we're close. And yeah, if we go up to here... Yeah, we just see this weird inverted stuff. So maybe part of the... Do we still have those opcode things on here? Okay, does this have short line? Okay, pictures created the open picture function in a color graphics export. Use the picture opcodes of the version 2 format. Yeah, okay, and it is horizontal followed by vertical. So, where are we screwing up? We've got a point DH and DV. I see. Okay, so we've got the pen location that it starts from, which would be what's it called? 2 16-bit. Signed 16-bit, yeah. Then DH, which is going to be a byte, and DV, which is going to be a byte. So why did I just implement draw point completely wrong? Or is the coordinate system different? Is that something you can even do? Like, this is such a specific type of weird output, and I don't quite understand. Alright, maybe what we need to do, if we were to just print the contents of the opcode as we did it. So weird. Such a weird thing. Okay, we have all these draw line commands. For the most part, they appear to be horizontal lines. So the y coordinate remains the same. Yeah, like all of them, the y coordinate is the same. Okay, so we've got like...
Check it out, boys. My magic bat.
I could use a magic bat. Not gonna lie. Okay, and to be clear, I didn't screw up writing the mask, did I? Because if I somehow like got X and Y mixed up there, that would be embarrassing. Yeah, so... Oh, wait. Okay. If it's the other way around, I'll turn this place into a car wash. No, it's X followed by Y. I'm glad. If they decided to put it in reverse order, that would be poor. X pause, Y pause, X pause, Y pause. Like this all seems... Okay. So then if we draw the exact stuff which is being scraped from the instruction. So it's exactly 6 bytes. And that should match what we're passing through to the internal function. Yeah, okay. So here are all the line drawing bits and pieces. Okay, and these are our deltas. So it's like 6 pixels, 5 pixels, 4 pixels horizontal, all horizontal. Okay. Oh, does it prefetch all the opcodes and then works on the stream version of the opcodes? Is that what this is? Like, I'm wondering if there's like an alignment issue and all of these opcodes are in fact not... Like it was off by like 1 pixel or something. because we have this, because the data is being fetched from this stream, and the stream is not, it's entirely dependent on the previous opcode having fetched the right amount of information, I think. Because, like, yeah, the, okay, so it reads 6 bytes from there. Oh, okay, then it, okay, so, no, it is, the opcodes are in line, I think. So that would imply that the opcodes themselves are good. What is this? Okay, what is this? Oh, right. Okay, no. Opcodes is the lookup table for, like, the types. It's not about opcodes that have been lifted from the file. That happens earlier. Okay, so it's looking for the opcode for draw line, which is 34, which is hex 22. Yeah, hex 22. Which okay, and that produces coordinates which are plausibly stuff about drawing a line. So why is it all just so weird and opposite of what we're expecting? Okay, and the rectangle is definitely, I think it's, is it top first? I think, yeah, I think rectangle is like y coordinate first, which is weird. Oh, wait. Wait a goddamn second. No, not that. Is the point structure the other way around as well? Because... oh no, okay. So the rectangle, the code here expects the rectangle to be x, y, x, y. But we know that that's not correct. Because 512 is meant to be the width, not the height. So like all these other ones, are they? I mean, yeah. I see. Okay, right. So I would hesitate. I want to say the pick loader code here is bad, or does not. It's not giving them the right. It's not doing it in the right order. I mean, like, sorry, the output is fine, but it is not. It's not really doing anything with them, so it's more just confusing than anything. But like, if I look here in toolbox.h, so the official definition for a rectangle in Quick Draw is top, left, bottom, right. So we would have to change this. Top, left, bottom, right. And then that makes me wonder, if we look at imaging with Quick Draw and we go point, like what's the point type? Like, do the points have Y first? Because that is the kind of bonkers thing that Quick Draw would do. Glossary. Point data type 227. And A4. Where's A4? Okay. You can't just say that it's 4 bytes. Tell me some more about like what's in it. What gives? Okay, 227. I need to know the order. 227. Okay. Point. Type bitmap. Type rect. Point. There we go. Case. So it is either like an array, but it is Y followed by X. I remember now. This here got me a few times, and it appears to have gotten the poor soul who put together the pick decoder as well. So it's actually Y and X. If I recall correctly, the API for shortline does, yeah, so the ones after that are X and Y, but the point is not. So that's what a stinker. What a stinker thing to do. Okay. Okay, sick. I've got a good feeling this is gonna be it. This is gonna make all our dreams come true. It's gonna fix the hole in the ozone layer. This code is gonna do. That's how confident I am. And if that works, then all we have to do is go back and remove all the weird print statements that we added. And I guess package it up. Yes! Okay. The transition is not there, but whatever. That's good. That's good stuff. Okay. So we'll pack up what we've got, and then I'm going to take a break because it's been a little while since I've taken a break. Okay, tell me how much of these two things I changed. A fair amount. Is what to say. What was the opcode? Short line. Okay. Also more right. Full rework pick handle to support masked drawing. Okay, that's the admin. All right, we'll be back in about 5 to 10 minutes. Go stretch your legs. we're back. Excuse me. All right. Where did we leave off? We racked up a W. We managed to figure out the bug in the PIC decoder, which was treating, well, it didn't realize that in Macintosh world, what's it called? Points and rectangles start with the Y coordinate as opposed to the X coordinate, which then meant, I don't know, this particular, where did this image go? Ah, it's here. All right. So this is what it's meant to look like. You've got some words. Those words are drawn using PICT, which is the Macintosh Toolbox's image format, which can contain either just plain bitmaps, which is 99% of the time it's that, or it could contain little, contain lines. It could contain any of the drawing instructions that Quick Draw. Well, not any of the drawing instructions, but there's a big, like, short line. There's all these opcodes for drawing lines, drawing colors, drawing text. Dear God, I hope none of these have text in them. That's going to be a pain. Because then we drag like the font manager into this too. But for now, we just, the line opcode is enough. And because, yeah, so it was this short line opcode, and then the data for that is the start point. But of course, in a kind of weird twist, this data type has YX, and then it is followed by XY. So we were just getting a bad result all around. But now we're getting a good result. I'm just going to turn off the graphics debug messages. So if that is sorted, then we just have like one mystery left, which is why the fade in for that bit of the doesn't seem to work. But that could have just been because we had like the debug messages switched on. So I'm going to try it without the debug messages. Also without any breakpoints, like all the stuff is timed based on cycles, and if you break with the debugger, then obviously that takes a lot of time. Okay, so come on, do the zap. Okay. So between the full portrait of her zapping and that picture that we got, there should have been a cool fade effect, but we got nothing, which implies I need to put in a delay so that because yeah, like another consequence, right, is that the original macOS code just, it ran as fast as possible, but there were bits of it which would, I guess, try and wait for a number of ticks, but like the upshot though is that because the screen is being updated 60 times a second based on the hardware interrupt, it didn't matter what the program was doing. Whereas now our code here, the only time that the screen will redraw is if there is a delay. So you can see here that there's like this delay instruction here, which then calls update screen, which in turn does all the, flips the page on the surface and draws to the screen and waits for the next frame interval and stuff like that. But effectively that means that if there's an area of the code which is just, waiting, like either busy loop waiting or I guess usually busy loop waiting, then we need to change that to use delay, or else the screen's not going to get updated. I think that that's why we're not seeing any action during that. So full prologue.cpp 999. So yeah, the bit afterwards is here in... Yeah, okay. Okay, and that's the fade pattern away from the screen with the treachery message on it. Okay, so it's a little complicated because this is also the part of the introduction which draws a bunch of stuff to the screen. So what's actually meant to happen, right, is that this is the part of the introduction where it loads more information from the floppy disk. So I think this is the setting the marker here. Okay. And yeah, so this bit here where it says delay from marker number of ticks D2, it basically means, it's actually quite forward thinking. It basically says you need to wait for hex D2 number of ticks since the last time that this marker was set. So the last time, which would basically mean that if this bit in here takes forever, such as because you're loading it from a floppy disk, that's fine. It'll then just subtract that from the weight, the fixed weight that's in here. So my guess is that the actual blit of this... Yeah, okay, so this... The blit is going to happen around here, I feel. So we've got these images up here, which are just cycling the little animation of her doing the zap. Then we cut to this here. Like, I think that I might have screwed that, like this code here. Because I'm not seeing anything that's... I'm also pretty sure that that's where the... like, I think there should be like one other call to toolbox here to invert the rectangle, maybe. Because traditionally, like, this is the point where... screen goes all screen goes all flashy. So let's pull up the source code for the introduction. Oh no, this is the source code for the game. I don't want the source code for the game. So change this to finale. Okay, and then we just gotta scoot down to 137 EC. Alright, 137 EC. Okay, so yep, so we have this call to blit page to screen. Then we have this call to set rect, which has been corrected. And then we have this little loop here. So it sets the tick counter to here. Yeah, okay, there's meant to be an invert rect command, which I've skipped out. G Z basic. Is it invert rect or invert rect? Okay, it's invert rect. And then we toolbox. Okay, then we delay for 1 tick. I was saying earlier that what I want to do is, because this game has like quite a few spots which really go nuts on the flashing inverse rectangles, it would be good to make an engine option for ScumVM to just reduce that to the WCAG recommended limited for strobing, which I think is less than 3 Hertz instead of 60 Hertz. Which is something that we can do that we can't do in the original. But yeah, the old Mac games really like flashing the screen on and off, because when you have 2 colors, that is your palette cycling. So we've got this delay from marker. Okay, now I want to check. Oh yeah, okay, so that's the end of the loop. Then we got some commands down here to set up a picture. Set up 2 pictures, really. And then release the resources for both of those. Then we got the tick count. Oh, I see. Okay. Then this is meant to, I think, show the treachery image. Because we're setting the port... Oh, actually, no. We're setting the port bits to the off-screen page. I mean, it might be that, actually. So we've got... Yeah, so like the way that the introduction works is it has like all these like off-screen surfaces or pages, and then it kind of blits them at the right time to the screen. So like page 6. Yeah, okay, so the last one that preloads is page 6. And then the others it just kind of creates picture handles for, but it does not blit them anywhere, which is important. Set port bits to pay. Okay, so by definition that must mean that this must be, I I guess this must be the right... Oh, okay, we've got these... We have these busy loops, which... Okay, which like draw stuff after that. Like I haven't... This game does use the Macintosh event system. I have not implemented all of it. I've just implemented whether or not you click the mouse. Because that's all the introduction needs. But we'll obviously have to... Let's do more. We'll have to try harder. Okay. What is... Alright, where's blip page to screen called? So... It's either blip page to screen or something which functionally does the same thing as blip page to screen. There are a few places which use copy bits. Screw it, let's just step through in the debugger. That's gonna be quicker than figuring it out via induction. So let's go 9:30. Okay, so it should stop just before, just after the lightning animation starts playing and just before all of that screen flashing starts happening. Yep, okay, good. We want to put a breakpoint in 939. There's going to be a lot of flashing. Okay. Now we get to here. So it's blitting pictures to the current Yeah, interesting. Okay, so we've got this close-up of the priestess. It's splitting to whatever the current graph port was set to. Which would be whatever the previous set port bits to page command was. Okay, so set port bits is set to page 6, which is the one that we just viewed. So it drew images D and E, I think, over the top. Okay, then it's setting the port bits to page 0. Okay, and then it overwrites a bunch of the off-screen buffers and starts drawing crap on them. Now it's drawing the sun. Yeah, okay, and now, as soon as we do this delay from marker... Okay, so somewhere in here is an implicit... we're missing something. As in, we are missing a weight. I imagine it is going to be... Yeah, what? Okay, like, how do you get the cool drawing... The cool drawing thing? I guess it's got to be somewhere between here and here. So let's just read through the code. Assuming I can find where the code is. Okay. This code. Okay, so we're measuring the tick count. Oh, sorry, we're writing it to the marker. Okay, then we do GZ basic unknown 52, which is something that's not implemented. But whatever. Then we call, yep, set port bits to page, which is this. Alright, then we call the internal fillrect method. Like, I got bored and I started naming some of these mystery functions. So, we have to compare them each time. Yeah, that looks good. And we have picture. Picture call looks fine. followed by release resource. Okay, then we've got a subroutine call, which is supposedly this render next text. Yep. Okay, then subroutine D2, then set port bits to page. Okay, then another fill rect, then another picture call, then release resource, then prologue next render text, and then D2. Okay, then we got another little loop. I mean, this was originally... Copying between the screens was originally done using the equivalent of memcopy, or memmove. But the original code also used, like, raw bytes for graphic storage. We don't. We use the surface type, so that's replaced with that. There's no other function calls. Okay, and then we've got all this crap about, like, drawing the sun. Pen pat, set rect, frame oval, pen pat, inset rect. Yeah, that's all good. Okay, then we finally get down to... Okay, and then there's another command. Okay, then we're here. We're at set port bits to page. Screen 6. Then we fill the rectangle with pattern 0. Then we draw a picture kind of smack in the middle. Then we call D2. Then we do a surface copy. Yeah, I believe that's correct. Then we call F48, which is this. Release resource, set the port bits to page 7. Picture. Set port bits to. Okay, no. Picture. Then prologue X render text, then. Oh, okay, I skipped a release resource command, which is not good. Yep, okay. Then we set port bits to page 8. Then we do another copy. Okay, then we call the fill rect command again. Yeah, alright, that's looking right. Then we split a picture. Then we release the resource. And then we set those port bits. Okay, and then we're up to here. 24A. Sub once we're at E80, and then it calls. Then it calls the scanline transition, which is the one after that. Huh. Okay. So I guess nowhere in there did I see code to gracefully blip things to the screen. Like, is it just that the picked code runs? I mean... Because, like, yeah, if we witness the original... Okay, 2 colors. Flashy flash. Interesting, okay, so... in the fast emulator, there is no fade in. Maybe that's just something that happens on the old Mac. That's very interesting. I did not consider that. Because it could be that maybe... because, like, hang on, if I open up MAME, which is emulating a Macintosh 2. Okay, please don't crash the stream. Please don't crash the stream. Okay, good. It's not going to crash the stream. And we do that initial... we do the prologue again. So you can see, I guess it can't draw lines as quickly in original Mac mode. Yeah, maybe just kind of... maybe it is literally just watching Quick Draw all of those lines with the line tool, as opposed to copying stuff, which is okay. It's perhaps not as special, but because I mean, like 3 and 3, for instance, like that has a lot of... do I have 3 and 3 in here? Yeah, so like another one of Cliff Johnson's games, which makes heavy use of Quick Draw. Come on, we want to get to the intro. Oh, okay. I thought it was another case where you could just watch things being drawn on the screen, but that I might have Mandela affected that. Because it seems like everything is just buffered off screen. Anyway, this is not a 3-in-3 reversing stream, unfortunately. That's going to be a ton more work. You know what? I am curious if I were to go into the DOS edition, the apocryphal DOS edition of Fool's Errand, and see how that renderer works. So here's the prologue of the much maligned DOS edition. Cliff Johnson, I guess, acknowledges that it exists, but isn't a massive fan of it. Recommend. His preference is definitely the Macintosh version because that was the original one. And you can see that there's a few. Yeah, okay. So the DOS prologue has a much worse font, and it does not do the kind of delayed draw thing. So I guess it's just a side effect of how fast the machine runs. Wow. The sun in this version is a lot smugger than the Mac version. Anyway. Alright, well we have, I guess that's a working introduction then. How much, what have we got? I'm gonna write a note for myself saying what's going on with the... Maybe we could add some generic way for the picked decoder to run a callback. between opcodes and wire that up to no, except yeah, that's not going to work though, is it? Can help given the image is decoded to a surface at stream load at load stream load time. Anyway. What's it called? So yeah, we would, I guess, yeah. Cause yeah, like Z basic. Yeah, it just calls draw picture. Whereas load stream actually does all the rendering for us, which is a pain. I guess what you could do is you could also have you could have load picks serialize all the opcodes, so you could just get like a big list of commands, and then once we have that list of commands, we could I don't know, detect for picture like the picture with all that stuff in it, and then pass it to like a custom method that draws the lines for us and stuff like that. Like, that's an option. I mean, I don't know. I'm happy with what we've got for now. Like, this is all stretch goals. Okay, but at least we know now. At least we know that that's an artifact of quick draw. Okay. So, got all of that out of the way. Now what do we work on now? What do we work on now? That's all the low-hanging fruit. That's the intro. Intro done. I mean, we could move on to the finale, but I don't know. I feel bad about spoiling that on stream, because I imagine most people here have not played Fool's Errand, and you should. It's a really good game, and hopefully once it's in ScumVM, it'll be easier to say, hey, go play this obscure Mac game. There's you don't have to do anything. It's all done for you. But until then, all right, I'm gonna spend the rest of the time, I think, just going over like the transcription that I'm currently doing, or maybe just getting the transcription up, like compiling, which I've not done yet. So I've started doing what's it called, copying over the code from the game proper, which is much longer than the introduction. Has a lot more to it, which makes sense because there are all these different puzzle types. It is... And yeah, like all I've been doing is I've got like 2 windows open. I've got this one here, which contains my crappy homemade disassembler, and I've got this one here, which contains bad C++. C++ that does not yet compile. And I am trying to transcribe what we've got here into bad C++. So where I left off was this method here, which appears to be something which draws text to the screen. It draws rectangles and stuff to the screen. What those rectangles are, no idea. Haven't a freaking clue. But the idea is that first we transcribe as much as we can, then we just get it compiling. We're not even trying to run it, just get it to compile. And then potentially, like, if everything is stubbed out, we can try running it and see what happens. So, given that we've done close to hex 1,000 CPU instructions, that seems like 479 lines of code. That seems like a good stoppage point to just start trying to make it compile. Mamu says, I don't think I've transcribed more than a couple dozen lines of assembly without validating that it works. Oh, you mean like converting it to a higher level language? I mean, for what it's worth, the assembly that is being output by ZBasic, it's very easy to read. It's childishly easy because it barely uses 2 registers. And also the disassembler that I put in here, I've tried to... Usually whatever the result... What's it called? Usually it'll either like try and write it to something to a variable, or it'll call another function. So I've got my disassembler here will insert a line break after those things, so it's even easier to kind of like pick out what's going on. Oh yeah, Manu says convert to high level language, step 3 validate, otherwise everything goes wrong. Oh, I don't know, maybe this will be fine. Maybe there's no problem at all. I mean, like honestly, with the introduction I was expecting a lot more crap to go wrong, but it's... To be fair, there are a bunch of transcription errors, but all of them were pretty easy to pick out because everything just looked bad. And you just put in a breakpoint at the point at which things started looking bad. Okay. 1086. Okay, so where we got to in this function, we have... So there's some... Yeah, this code does some interesting things where it will treat string memory as bytes that it can use for like toolbox calls and that. We're gonna have to isolate each of those to use the correct typing, I think. Like, we had a similar thing going on in the introduction. It would kind of allocate 12 screens worth of array and then use that as de facto surfaces that it would just copy around with memcopy. But for like ease of management, we got rid of that and then just used the surface type. Oh, Mad Moose says the code I'm reversing is also written by a crazy French man. I mean, yeah, the French, lot of galaxy-brained French demo sceners is what I'll say. Like, there's, I mean, like, think about like Alone in the Dark and Little Big Adventure, like all of really pushing the envelope for graphics at the time. Also, Click Team I think came from France. Did Click Team come from France? I think they did. Yeah, they must have. 1086. Okay, so here's an example of what I think this is like an event handler. Because I don't own ZBasic version 3, I don't know what the event handler is for. It looks like it's cleaning it out. So for now, I'm just going to mark this in as pencil this in as an instruction. I don't know what the hell it is, but it's clearing, it's clearing a word. Okay, and then this is interesting. Okay. This appears to be the end of a loop because it's got like a addition and then a comparison and then a jump. So that would mean that like 105C, which is at the beginning of this buffer concatenation step. Okay, and then 7B8 is being used as the loop point. So this is actually so we'll say 128, 1056, and then this becomes a for loop for int I equals 0, I is less than, so we've got greater than or equal to, so the inverse of that is going to be less than, and it's comparing it to whatever's in V, okay, 7AC. Yep, that's adding 1. Okay, and then it's also adding 11. Okay, and that's different from 7AC. Yep. Okay, good. And then outside the loop we have 128, 10.0, 8.0. Ah, okay, and then we just gotta straight up jump. Oh crap, and we've got another loop condition here because we've got a BNE, which jumps back to 10AE, wherever the hell that is. Oh wait, no. This is just it's just a conditional. Okay, easy. So if var 16 7AE, it's not comparing against anything else, so it's going to be comparing against 0. So it's going to like, if it doesn't equal 0, then, so if it doesn't equal 0, then go to the next piece of code, which is what we want. A lot of double negatives that you got to be careful about. And then after this block should be 128, 1784. And inside this block, it should be, okay, G toolbox pen normal, G Z basic text. So then it's going to be C. Actually, no, it'll be 0. C 0 1. Okay, now we got a little bit more complicated stuff, which is going to be like an array offset. Ooh, okay, interesting. Okay, so this is setting a word to 0. Okay, and this is memory, which is clearly a rectangle. So I don't know why it is setting... Oh man, yeah, this code does weird things with rectangles. It just kind of assumes that they're interchangeable with arrays, which in many respects they are, but not in here, because that's like one of the cases where we switched to like ScumVM's built-in class, and it is of course different. So we've set... Okay, but this is just another loop. You can see here it checks to see 68A, and then it jumps back to 10C6. So it is comparing to B. Okay, right, because there are two rectangles. There is one at 57BC, and then there's another one at 578. Oh, sorry, 5B7C, and then 5B8 something, I think. Yeah, 5B84. So if we have to kind of translate the intent of what this is. It seems to be just zeroing out everything in the rectangles. So we can rect 5B7C. And then we go 5B84. Imagine. Yeah, okay. Okay, that's all good. And then... Wait a second, no, that would... Okay, so this is B, which is the number 12, which would imply that there's four words worth. So there must be one that's also at 5B8C. Okay, and then we've got... Okay, this appears to be like another... It's using another variable that's with a loop. Oh, alright. This looks nasty. This looks very messy. So we'll just keep chugging through. 128 10E2. Oh, interesting. Okay, so we've got comparing whatever's on the stack. So if this equals 1, then we do all this, G toolbox set. Okay, and then all these instructions are here. E2, this var I16 7VC, 11E, plus 14. Okay, then it jumps to 117E. Interesting, okay. Because, yeah, we've got 10.0 F6. I'm really hoping, I mean, most of the code so far has been non-go-to written. If there are go-tos in this, then we're gonna just have a horrible time. Yeah, alright, so if it's equal, then we've got this. Then it jumps to 117E. Yeah, okay, that makes sense. .117E. Okay, so we go to Ooh, this is mildly optimized. It doesn't push the thing to the stack twice. I16 7A equals 2. Okay, and then we have E2 11E. Oh wait, no. BF 7VC FB plus 14. Yeah, alright. Alright. I'm not sure how this is all meant to join together. I mean, okay. 1206 kind of seems like a shared finish point. We might have to, okay, we might have to collapse all this afterwards. Like, I guess this is just like an else if. It looks like an else if. As opposed to like nested, but we can collapse that in a bit. Alright, and then that becomes like if okay, what do we got? We've got 5B7C. Okay, 9C D8. Five B8-4. That becomes E2. 1-1-E. Okay, and then we got the third rectangle, which is going to be 128, 164, plus that. And then now, okay, another conditional. If this for I16 7A E okay, if this variable -1 is greater than or equal to 0, okay, so this rect 5B7C A. So like this is an example of a function that we've not implemented yet, but we will probably have to get around to that. Okay, and then stuff involving the string buffer, which I'm less than excited about. Okay, is this another loop? No, it's not. Okay, this I32 1A8D8. plus 1 times 66. Okay. Okay. I wonder what part of the game this is. Like, this must be... It's incredibly draw. Like, look at all these things that it's drawing. I don't know. There are some... Nah. No idea. Very difficult to tell without context clues. Okay, so this is pushing the 3 rectangles. Oh wait, but it's not pushing the 3 rectangles. It is pushing one of the values from the 3 rectangles, because you can see it's getting a single word. So where do the rectangles start? Okay, it's like 5B7C. It's top left. Okay.
Your engine oil pressure is critical.
Oh, thank you very much for the follow. Fat Crow. Good to have you around. Yeah, alright, so we know that the rectangles start at 5E7C. This is referencing 5E7E, which would be the left component of each of the rectangles. Which is odd, but okay. 128, 1274. I guess we'll just write these down. Rect 5E7C left. This rect 5B8. Oh, actually, no, hang on. This is all the same rect. 5B7C. Right? Yeah, because it'll be off by another 4. Yeah. Okay, so we push these 2 numbers. Then we push the left one again. So we have to kind of do a little bit of like stack math stuff. So we've pushed 3 numbers to the stack. We then have to assume that we're subtracting... Okay, so we're subtracting right, left from right. Actually, no, sorry. Like, left was the last one that we got. So we're in the world of double negatives now. So we have... Left is in DO. Right is in D1. And now it is left that's in D1 and right is in DO. So we're subtracting left from right. I think that's right. So left is moved into D1. And yeah, okay, we're subtracting left from this number here. Okay. So that gives us this, and then we're dividing all of this by 2. And then we're adding this. Which makes sense. We're finding the middle point. We're finding the middle point of the rectangle. Okay, good. And then are we saving it somewhere? Okay, yeah, and then yeah, saving to var this var I1630 is equal to that. Actually, no, crap, no, there's still more. So we've got this number here, we then push that to the stack, then we get var I1630 and divide that by 2. And then subtract this from that. At least I think that's the math. And then we move. Okay, and then that gets thrown into this I1630 equals this completely mad thing. I don't know, dollars to donuts, I'm going to get that calculation wrong, but it doesn't matter. It's not like we're not going to test it tonight, because we're nowhere near there yet. We don't even know what this code does. Yeah, okay, 12CA. Oh no, 12D4. Okay, oh, actually no, I missed one. Move to. Is greater than... Okay, so if it's greater than... Is greater than 1. Then we have all this. Oh my god, this... I am kind of glad I'm doing this on stream, because I would absolutely lose interest at a function that's this long. Normally. Rect 5B7C. Five 0. Don't know why it keeps auto-completing 0 to be 0E. That's quite irritating. Frame round rect is going to this rect 5B7C. See, this is nice. I literally just... You don't even have to think when you're doing like these drawing commands, because it's literally just copy pasta almost. Oh, okay. Now, where did the previous one say would be finished? At 134C. Okay, Ooh, alright. Now we got to 134C, which means we're outside the loop. Mercifully. Okay, so finally we go if this var I16 7AE is greater than or equal to 2. Five B84. And then all this junk. This is gonna be another loop. I don't care. Extend, yeah, okay, so +2 times 66. Figuring out what type this data structure is gonna suck. That's my takeaway. My guess is that that's gonna be data loaded from the puzzles file. So we're just gonna have to figure it out. Push W. This faster 172. What number is 66? 102. I guess. Weird choice, but okay. I respect that. Okay, we have another thing which is accessing various bits of the rectangles. This time it would be accessing this one here, which would also be, I'm going to assume it's probably the same calculation. Yeah, subtracting. get to... minus whatever this is. Okay, then we're outside. Oh my god, there's still more. This doesn't end. Oh, I've just not been paying attention. Kinnicker says, I may be a bit obsessed with this game. Level 10 is the highest difficulty, which the game calls a letter of complaint in the menu. Oh, okay, this is Star Quest, the simulation title you were talking about earlier. Yeah, it's good. It's genuinely good when games are, I guess, both unapologetically hard and then apologize for being hard in a backhanded way. Like, that's also kind of funny. Okay, well, it's all okay. We've got like an hour left. I can't. I don't want to do more of this function just now. I will, just not now. What I'd prefer to do is I'd prefer to add it into the build path and watch it just die. Let's just absolutely eat it. Okay, so engines full. Congratulations. It's now load bearing. All right, who wants to take bets on how many errors there are? I'm guessing over 100. Oh, it might be slightly less than 100, but that's also because there are syntax errors. And also I've not done any of the typing in here, so it might be letting us off easy. Okay, let's just quit out of here for now.
Listen and try it with the musical drum key.
Ah, thank you very much for the follow, Desec. Good to have you around. We are. Okay, so how did I do this for the original? For the pro... Okay, so for the introduction animation, I just marked all these variables as private. So I guess we'll just add a private section. and start stenciling the arrays, the variables that we know are correct. So we know that 5B7C, 5B84, 5B8C. We've confirmed those to be the correct type. Include common rect.h. We also know that vaster 172 common string vaster 172 is correct. Honestly, was expecting a lot more errors, but it's it's mostly whinging that the functions aren't defined, so maybe that'll translate into worse errors once we fix all of those. But whatever, we can go through and add those. Are all of these... Okay, all these methods are public. That's fine, we can do that. So let's just go through and add in all the methods we've had so far. Full game. Int 16 sub 128 446. Int 16 sub 128 462. Void sub 128 49A. Oh, Kinnick says, it's funny, I don't really care for racing stuff, yet here I am trying to master it in StarQuest 1. Is it like a... I want to say like a logistics kind of simulation, like doing trades and stuff like that, or is it just more of like a combat element, or like what's the deal? What's going on? Sub 128 40A. Int unc1. Int 16 unc1. Okay, now we're getting up to the ones which have like a ton of variables. Which I'm going to be more happy about copy and paste. Sub 128.5C. Kinko says, it's just a space combat sim, but some of the missions you can select are 3 different race courses. Is the, does the engine feel good for racing in? I suppose is the follow-up question to that. Okay. Oh my word, there's so many of these. There's so many. Oh, this is just like a quarter of one module. There are, I think, 16 modules in the game. It's either 14 or 16 modules in the game. Okay, there we go. That's all the definitions, at least so far. Alright, now we're into major error problem territory. Kinnick says, and you have 10 other opponents to deal with in the races. It's not a realistic Newtonian physics sim like Frontier Elite 2, so yeah, honestly, if there was a fucking Newtonian physics model in a space sim and it had race courses, I'd lose it. So, as in kind of like, when we're talking Newtonian physics, we mean like planetary bodies exerting gravity kind of thing, so that you can slingshot around stuff. The whole 9 yards. I mean, yeah, it would be... I mean, I guess like Kerbal, you know, Kerbal Space Program gives you an idea of like how you need to plan your moves like well in advance in order to deal with quirks of the, you know, inertia and gravity and stuff like that. I just don't, yeah, like, it would be interesting in like an arcadey kind of racing context, but it would be, I don't know, easier to do in a way that was not very fun, is my guess. Okay, now it's just whinging that Toolbox doesn't exist. That's a legit grievance, but easily fixed. Okay, never mind the fact that we don't yet have a run function, because we don't call the run function. Oh, and I gotta load in. Okay, where are we at? We're at... So we need a new function in ZBasic to deal with this. We need... Okay, it's going to ask us to deal with that string, which I hate. Vaster 384. Oh, did I not declare... this here? Okay. Okay, so now we've got to like start thinking about the boundaries for some of these chunks of memory. Like we have an array which has definitely got pen patterns because it's being, what's it called? The contents are being sent to the penpat function. But we don't really know how big it is because that gets crushed down as part of the instructions. However, we can look at the unique addresses that are referenced from the heap and then just make a educated guess about where the pattern array begins and ends. So we've got 5, 8, F4. Oh yeah, and a pattern is 8 bytes long. So and we've got 5, 8, F4, 5, 8, FC, 5, 9, 04, 5, 9, C. Okay. That looks like 4 colors or 4 patterns to me. But potentially there are more, but we have not. I don't think we've found the thing which initializes the pattern buffer yet. So we'll just go to here and add a variable called and say that it is 4 things long. I think that's how we do it in here. Yeah, okay, we just do it like that. Okay, this is definitely an int16. It's used for a bunch of things. We don't yet have... Okay, we're gonna have to add in some more toolbox functions, which we don't currently have. It's great. Love adding in more toolbox functions. Don't have to point to anything yet. They just need to be there. Erase round rect and frame round rect. Ah, what? No. It was here. Oh, okay. Stockless one also has a very odd mechanic where to recharge your ship, you need to position yourself next to the sun. It's kind of like Elite's fuel scoops, but you don't have to worry about cabin temperature, nor do you need to be literally moving across the sun's corona. That's generous. Nothing like... I imagine that could also be kind of hazardous if the sun's gravity works like the sun's gravity. And you got to be just close enough to scoop up the hydrogen, but not so close that you fry. Kinnigo says you will instantly eat it if you literally collide with the sun. Okay. I think that's fair game. I think you should eat it if you, at a minimum, you should eat it if you run into the sun. So we got erase round rect. So what does it take? It takes common rect. Right. So there's now a definition for that. Frame round rect. Invert round rect. Fill round rect. Frame round rect. Okay, that's the same parameters as this. Any other toolbox stuff that's missing? I guess not. I guess... Oh, okay, I got a syntax error there at 264. Okay, and then just endless variables. Oh, okay, I screwed up one of the definitions. 2BE. Okay. Okay, develop conversion to source mode. I think it's or. Yeah, okay, it's that. Okay, has no member name 3A. Alright, 3A is definitely a variable that we have. Huh. Five B84. Okay. Has no member named 5P7C. Hmm? Oh, I got it around the wrong way. I'm pretty sure. 128 OD 34. Five B7C, yeah. It's 54. $44. Okay, so there are functions which refer to these other functions which we gotta eke out, I think. So what's the first one? 4472. Is it really 4472? Because this appears to be in the middle of some other code. Did I write that down wrong? So 128 OBDE. Four 472. Must be correct then. Must start in the middle of nowhere. It's using an odd number as an index, which is concerning. Actually, no, it's setting it to... No, I'm doing this wrong. It's setting 47581 is equal to 31. Oh my god, so I'm not even, like, not even paying attention to the right thing. If this doesn't equal 0, or if it equals 0, then go through and do all this other stuff. 47581. Frustrates me so much. Oh, what have we got here? There's so many push statements. Oh, okay. It's calling sub 128.962, which is the one which has 11 arguments. And hopefully I've reversed them, so it should just be a case of typing them in as they show up here. So 130, 76, 130, 76, 14, 0, screen height, screen width. 47581. This I16 47582. 19. Alright. And then returns. Oh wait, no, it does not return. So this returns. but this function here. But if we don't pass that check, then it jumps to this completely different thing here. Okay. Ooh, and it's using the pattern buffer. Okay, and then after setting the mode, we get to here. Oh my god, which is even more drawing code. Okay, so then like this I16 4758. So we got 8 ACE 0 2 75. It's setting all these numbers, and I'm not entirely sure what they represent. So for now, we'll just keep pretending that they're part of an array. Because if it was a group of 4 that was all stitched together, I could conceivably think that that would be a rectangle. Except that's more... Okay, that's not 4 together, because there's a big gap between this one and this one. And then this one is using 4764 as the pen size. Like, this is mad. Why would you use the array store for this? This is just confusing. I don't feel like typing all this in. We're just gonna stop it. Pen mode set to this, and then we check here. Now I gotta do some more that are on the edge of the world. Can some of these be small, please? They don't have to be huge. 5v30. 5v30. Look, it's like one instruction. That's great. We can totally write that. Void. Full game. Sub 128. 5v30. Oh crap, okay. Cool, alright. Also, I need to fix my disassembler because there are traps that are missing. So... I'll just put fix me in there for now. What trap am I missing? I thought I got them all. At least all the ones that were in use. A9 3D. Menu select. Ah, that's a fancy one. It's a very fancy one. Behold the massive switch statement containing every single trap that we ran into. A9 3D. A8, A8. So I mean, what we're looking at here, right, is that the way that the Macintosh Toolbox API works is that it will just... There are certain instructions in Motorola 68K which are just invalid. However, if they begin with A, or if they begin with, I think, F? Yeah, then there's a special exception mode which can be used to emulate other devices. And Apple uses this to just run arbitrary code, basically. So Kittiger says, so Macintosh is basically a gigantic 68K hack job. I mean, I wouldn't call it too much of a hack job. Like, this feature is part, like, it was designed specifically so that you could emulate hardware. So it's not too much of a stretch to say, okay, just use the same mechanism to call, and it doesn't call the toolbox ROM directly, it just calls an interrupt table, which can then be replaced by, like, if you've got System 6 or whatever running on the disk, like, then that can swap out its own methods for stuff which is... So they were thinking, like, several steps ahead about how to kind of make programs forward compatible and interoperable. So 8888 is... Okay. Ooh, this looks like an actual instruction that we're not disassembling properly. I'll get back to that. 8937 is draw menu bar. A94B. Plot icon. Oh, crap. That's why. Okay, got a few oddball instructions. Fill round rect. Okay, we're definitely gonna need that. Oh, okay. This just isn't... This isn't in order at all. Why did I think this was in order? Oh. In fact, we have several duplicates. D. Okay, that's in the correct order now. Get M handle. Oh, okay, that's another menu function. A949. Oops. 20. Okay. I think it's. Yeah. Where did... Oh, crap. Here it is. A936. Delete menu. I guess I could just take these from a database full of trap calls, but it's also nice to kind of have a record of like which ones we need to implement versus every trap call. So I don't mind the busy work of writing this down. And 32, which is dispose menu. Yeah, okay, we got him. Find next. No idea. No idea. A938 is highlight menu. A93E, which is going to be menu key, whatever that is. previous A874. Let's get port. It's quite an important one. Oh, yeah, okay. So I'm a little worried about that because that would mean that there's code that either writes to the graphics port structure directly or expects to be able to give it to something else, which could be hazardous. Or maybe it's fine. Maybe our emulation will cover it. Maybe we do not have to worry about it. Oh, no worries, Kinikos. Enjoy your star captaining. We're about to wrap up anyway, so. It's 74. 89 BB. Get icon. I guess this must be about like drawing the fancy pictures in the menu bar. Which is interesting. Shit. More bad instructions. A9C8. Sys beep. Oh, okay. This has got me intrigued because initially I thought this game did not have any sound, but certain, like the word search plays like a little kind of crescendo, you know, a little kind of what's it called? Little arpeggio when you get a big word. And I think it must be using sys beep to do that. So that would be cool to look into. The later edition I think stripped it out because it didn't quite work. A9C8. Yeah, what? Some boring instructions, and did I miss a previous one? Erase rect. Erase rect. Text mode. Oh, okay. I think that just changes the blitter mode as opposed to any kind of like Macintosh doesn't have a text only mode. It better not. So 8, 8, 9. Oh yeah. Oh god, okay, it does use the polygon drawing code, so we're gonna have to write a polygon renderer. I mean, I think the primitive thing might actually have a polygon renderer. If it does, that's good news for us, because then we don't have to do it ourselves. Oh no, it's invert poly. F4, which is close picture. Fill poly. It's C6. Frame poly. A8, 8, 9, which is okay, which is one we already got. C6, which is one we already got. Okay. Oh, I thought I put that in. Right, okay, no, I got this wrong. C8 is erase poly. Nearly there. A3, 2. What? Huh, okay. That's not in the trap list. Could be that maybe it's detritus from these other instructions. And so not an actual trap. A8CA. A3, 2A. Yeah, okay. That's it. We got all the... I guess all the missing traps. We've not fixed the instructions, but whatever. I gotta figure out how to make the 68K assembler work to figure out what those are. Or at least the decoder. That's okay. It's quite late. I think we'll just leave it there for tonight. Yeah, I will... I guess I'll continue trying to kind of get this to build in the meantime. Mr. RW1 says, has anything been put into the daily builds to try out? This is not part of mainline. I'm developing this all out of tree. There is not really much to try out yet except the introduction, which we just finished working on. But no, yeah, we're now just maybe like a very small distance into transcribing the game itself. Like, my hope is that first we, initial plan is that we transcribe module 1 of the game, and I'm hoping that should be that should be enough to at least start it, and that should give us an idea of which module is the book, which is like the interface that you use for like viewing the story and going to the next puzzles. And then we'll just work on them like piece by piece after that. And then should be just a case of like, okay, we've encountered a puzzle which needs one of the code modules which you haven't done yet. Let's just do it module by module. And then that way we don't have like the weird, you know, the horrible monolithic experience of having to kind of translate everything, then debug everything, then type everything, and then have a whole bunch of stuff that doesn't work. So yeah, that's it's unfortunate that module 1 is just so big and it's going to take a considerable amount of time. But lucky for you, I can do most of this just sitting on the couch. It's just a big time sink, that's all. Like, I did 300 lines of this on Monday, just sitting on the couch. Ugh. Anyway, time to wrap it up, I think. Who is doing stuff? Following. Oh, I might have to raid Summer, who is playing Svoboda 1945 Liberation, a historical WW2 FMV adventure game, and I love me some FMV, so we're gonna raid Summer, go say hi. I'll be back on Thursday. We will probably do Director again on Thursday. I don't want to do scanner stuff on Thursday. Doing that once is enough. So yeah, we'll try and get back onto the regular swing of things, but until then, have a wonderful rest of your day, and I'll see you next time. Goodbye.